Okay, so welcome back to the Calculus Analytic Geometry once again. I hope you have watched the previous lectures and enjoyed them, and you have been working hard on solving the assignment that I have uploaded on Moodle. And soon we're going to have a Zoom session in which we'll discuss your all queries and questions that you have, for example, about this session and the previous session as well. So what we are going to do today, we are going to meet with a very, very interesting topic of differential calculus. Probably this is the one of the topic that is very popular among the computer scientists, engineers, among the economists, among those who want to study, for example, biology mathematically. Okay, so what is that topic which is kind of popular? So the topic that we are going to discuss today is about the optimization actually. In other words, finding the maximum and the minimal values of the function. Why this is important? Imagine a situation where you want to make an investment, you want to spend some money, you want to, for example, buy, you want to start a business, you want to do, for example, investment in shares of a company or whatever. You want to make an investment actually. One of the obvious questions that you will be interested in that okay, if I am making this investment, then what is the optimum or the maximum profit that I can have in this investment? Or you will be also interested in the question that if God forbid, if you are losing money, then what is the maximum amount of the money or the amount of the investment that you're going to lose by making this investment actually? So optimization is all around us. We always try to optimize the thing. We, for example, you want to optimize the performance of your device. You want to optimize the performance of your computer. You want to optimize the performance of your software. In other words, and what do you mean by optimization? Trying to get maximum benefits out of something, trying to have a maximum output, out of a process actually, with the minimum cost actually, okay, with the minimum burden, with the minimum anything, okay. So what we are going to do in today's discussions is that we're going to talk about the theory of the mathematical theory of optimizing the one variable function. This optimization also go on, when you, for example, deal with functions of more variables, then you do also optimization there, and then it also becomes something very interesting. But we will see that even in one dimension, in other words, the function depending on one variable, their optimization also give you some of the interesting results. So what we are going to do today, we're going to take function of single random variables, and we will try to mathematically define what do we mean by a maximum of a function, what do we mean by a minimum of a function, when a function attains a maximum and when it attains a minimum. How can I find the maximum and minimum of a function without looking at its graph actually. And in the end we will also talk about basically some of the applications, that how you can take a complicated kind of a function and you can make its rough sketch easily by knowing its optimized value, its maximum and minimum value. So all of this stuff is that these are the few things that we're going to cover in our in today's discussion actually. Okay, so let's start with analyzing a function. So let's imagine I have a time t, okay, t that represents time versus profit axis. Okay, so P is the profit actually. Okay, So time versus what do you call the profit axis. And you are making an investment, and imagine your profits on your investment goes like this actually. Okay, something like this, or maybe I should make it like that. Something like that. Okay. Then by looking at so what would be the interpretation of this graph? So you're going to say that after this instant, so at this instant you started counting your profit, and your profit was this, okay, and then your profits went down and then went up, okay, to a peak, and then went down again, okay, and then went up actually again, okay. So your profits are constantly, okay, your profits on your shares or investments are constantly, what do you call, going up and down. Now obviously by looking at this picture, okay, you can say, if I ask from you, what is the instant when you had maximum profit actually? Okay, what is the instant when you have maximum profit? So you're going to say that, okay, this is the instant, for example, let's call it C, where your profit is maximum. Okay, and what is the instant when your profit is, for example, minimum? So you're going to say that the minimum profit that you have gained on your investment was at, for example, this instant. I don't know, let's call it D actually. Okay. So at time C, you had the profit, what do you call, f of C. If I call this function as f of t, and at time D you had the minimum profit, what do you call, f of t. Okay. So this shows your minimum profit, this shows your maximum profit. This is also another kind of a minimum actually. Okay, but we will talk in a moment about it. Now here's the thing actually. I'm looking at a graph, and by looking at the graph you can easily tell that, you know, when your profits were maximum and when your profits were minimum. But imagine if your profits are written, you know, you don't know the graph of the profit, but you know the model of the profit, or you know the function that represents your profits actually. Now the question is, can I, without looking at the graph of your function, tell that when your profit, at what instant your profits are maximum, and what is that maximum profit, and at what instant you had minimum profit, and then what is that minimum profit as well? So I'm interested in, you know, what do you call the minimum and the maximum profit actually. By the way, let's say that this is the domain of the function actually. Okay, let's call this as, what do you call, the domain of the function. Okay, so from this instant to this instant, let's call this A, let's call this B. So the A to B, so I have this profit function defined on A to B, and I'm interested in that in this instant, in this time interval from A to B, when my function is giving me maximum profit, or my investment is giving me maximum profit, and when it is giving me the minimum profit actually. So returning back to the question, if you have the graph, you know everything about your profits, but imagine you don't have graph, but you just have a function actually. So one way is that, okay, plot that function and see that where you get minimum and where you get maximum. But the interesting challenge would be that can I know about my maximum profit and minimum profit without looking at the graph? The answer is yes. The question is, how can I say? How can I say that, you know, which profit is the maximum profit and which profit is the minimum profit actually? Okay. So if I ask from you, look at this picture, and why this point and I ask from you that why this point is a maximum point, or why this point is representing the maximum profit and why this point is representing the minimum profit. The simple answer is, okay, you can reflect and think about it for a moment, you can pause the video and think about it, but the simple answer is that in this given domain, so in this time period, this is the maximum value. This value is bigger than or equal to all of the other values that you have in this domain. So this value is bigger than or equal to all other values, think about it, that you have in this domain. So therefore you're going to call this as a maximum. While this value, why this is minimum? Because this value is smaller than or equal to all other values that you have, on this curve. So you're going to call this as, what do you call, the minimum value or the minimum profit actually. So keeping in view this consideration, I can formulate, a definition for a maximum actually. A maximum or a global maximum or an absolute maximum. So let's observe this again, once again. Why this is a maximum? This is representing a maximum profit because all other profits, all other values of f are smaller than or equal to this value on the curve in the given domain. And why this is minimum? Because all other values of the function are bigger than or equal to this value, okay, in the given, what do you call, domain actually. So you're going to call this as a minimum and this as the maximum actually. So this is like the maximum of the all values and this is the minimum of the all values. And we call such maximum as absolute maximum or the global maximum, and such a minimum as the absolute minimum actually. In other words, if the value of a function is bigger than or equal to all other values, okay, in its domain, you're going to call that as a maximum, but you're going to also call it a global maximum or an absolute maximum. While this minimum, is, since, what do you call it, is a kind of a minimum. By the way, see, this is also a minimum actually. But this minimum is bigger than this minimum. So I'm going to say this is the smallest minimum actually. Okay, so there is no other value which is smaller than this. So you're going to call this as this is global minimum or the absolute minimum actually. And how to decide something is minimum and something is maximum? Simply, if the value of it is bigger than all other values, and if this value is smaller than all other values, you're going to call them maximum and minimum respectively. So let me put this observation and let's try to write a definition for a given function and its maximum and the minimum value. So here's an interesting definition. Okay. So let's see be a number in domain of function f, okay, then f of c is I'm going to call this f of c or the value f of c as an absolute or global, there are two names, okay, global maximum. When this would be global maximum? If this value f of c is bigger than or equal to all other values actually in the domain x actually. In other words, no matter what value of x you take, no matter what point from the domain you take, and you compute its value is always less than or equal to this f of c. So you're going to call, aha, this is like the king actually, the maximum, the absolute or the global maximum. Similarly, what should be the definition? You can guess already. What should be the definition of, say, absolute or global minimum? If the value at C is less than or equal to all other values of f from the domain accepted. So if this is less than or equal to all other values in the entire domain, I'm not talking about the part of the domain, in the entire domain, then you're going to call this is the smallest of all values. For example, this, in the case of the profit, this is the smallest of all profits, and this is the greatest of all profits because it is bigger than or equal to all other profits actually. So f of c is less than or equal to, greater than or equal to f of x. If this is true for all x, then your c is a global maximum, and if f of c is less than or equal to f of x, okay, for all x, then your f of c is minimum. So I hope that if there are global maximums or absolute maximums, then the question arises, are there, local maximums as well? The answer is yes. So how you can do it? So all of this is what you call the domain of the given function f, and this is the absolute maximum and this is the absolute minimum. But imagine now I'm saying that I'm not interested in the entire interval, entire domain. I'm interested in only this part, say this part. That in this part, okay, in this part, what is the maximum value that function attains and what is the minimum value that function attains? In other words, in this time interval, what is the maximum profit that you make and what is the minimum profit that you make? So now you're going to say obviously that, okay, the maximum profit that you make in this interval is this, and the minimum profit that you make in this interval is this actually. Are you getting the point? But you have to keep in view that this maximum is not a maximum for the entire curve. This maximum is maximum for only this part of the curve actually, or this part of the domain. So this is maximum in this part of the curve. So it's not maximum on the entire curve. And this guy is minimum. Why it is minimum? It is minimum because that in this given interval, okay, in this small period of the time, the smallest profit that you have is this. So you're going to call this is a minimum, this is a maximum, but this minimum is different from this minimum. So I'm going to call this minimum as local minimum actually, okay, as the local minimum, while this is, I'm going to call it a local maximum, okay, a local maximum. This is local minimum and this is local, what do you call, maximum. Now, and this is important to realize actually, that a local maximum and minimum is not true for all, what do you call, the domain. It's true for some part of the domain actually, okay. So, well, you can have a, what do you call, you can have the situation that, okay, if you are working in, for example, a company, okay, then, really the CEO of the company or the owner of the company is really the maximum, okay. But it can also happen that, okay, you are working in a unit in a certain department, and in that department there is a head. Now that head is also maximum, but that is maximum, but he is or she is maximum for only that department, not for the entire, what do you call, company. You know, the maximum for the entire company is that boss actually. Okay. So similarly, this is the maximum for the entire curve. Okay. And this is the minimum for the entire curve. But this maximum is maximum for only this time period, and this minimum is minimum for only this time period actually. Okay.